Next, we'll look at the branches of statistics, as it were, where here we make what I consider a bit of an unnecessary dichotomy between descriptive and inferential statistics. And even though I'm not a huge fan of this, I should still underline it to be sure. Where what we're looking at for descriptive statistics is essentially representations of data. It's where we're looking at collecting and describing what we find. Think things like graphs, tables, diagrams, just representations. Whereas for inferential statistics, we're looking at how we can draw those statistics in order to make conclusions and interpretations about the population as a whole that ideally the sample would be a representative of. Now, again, I do think of this as a bit of a false dichotomy because realistically, if you're looking to draw a conclusion, you're going to want to be able to present your evidence in a meaningful way. And usually when people are presenting evidence, they're not just doing it in some pursuit of objective truth, they're usually trying to make a point. So yeah, we present these as separate, but it's kind of rare to have a study to draw statistics in such a way that you're really only looking for one or the other. Usually you want both. But in any case, we're going to look at an example here talking about this distinction, where we have a study of 300 Wall Street analysts that found 44% incorrectly forecasted high-tech earnings in a recent year, indicating that predicting the stock market is difficult even for the pros. What are the population and sample in the study, and how are the two branches of statistics used here? So here, what we're looking at are forecasts. So our sample somewhat, I don't know if oddly is the word, but a bit, I'm drawing a blank on the word at the moment. Maybe I'll toss it in here in a subtitle. But the point is, our sample ends up being the set of forecasts, actually, because we found that 44% of forecasts are wrong. It is a little objective to look at the forecasts as devoid from the forecasters, but we're focusing on what they say. The predictions. So our population here would be all possible forecasts. Any prediction made by an analyst, where the use of descriptive in this case, the descriptive stats here, oh, I don't know where that T came from. It was getting a little ahead of itself. These would be the percentage that we're seeing. It's the presentation of the data that we have. The 44% wrong. And then on the other hand, the inferential statistics used here would be the conclusion that we draw. Where in this case, our conclusion is that forecasting is hard. It's not easy to predict the stock market, even if it is your job. It's an inexact science. It's a bit of gambling with some extra steps and usually a lot more money. But that's how we use inferential statistics here, is to make that conclusion based on the data we have, based on the description of the data we have, that is. Although, when it comes to inferential statistics, it is kind of a matter of opinion, right? How we want to read this information. Some might see this and say that drawing conclusions is difficult. Others might say, well, hey, that means 56% are right. And for a lot of people, odds better than a coin flip are odds they're happy to bet on.
Yeah.
If that wasn't the case, craps wouldn't be so popular, neither would blackjack. These are pretty nice for someone who sees things with a little more optimism in their gambling tendencies. But anyway, that's all we've got for section 1.1. Next, we're going to move on to 1.2, where we'll talk a bit more about types of data.